Hello students, let us solve a problem from NEET UG Paper 2020. Here is a problem. It is from Boosters law, and here the question is asking you to find out the Boosters angle IB for an interface. So whether it should lie in between 0 and 30 degree, or 30 degree and 40 degree, or in between 45 to 90 degree, or it should be exactly 90 degree. You have to find out the correct answer. So this is from Boosters law. So let us understand a little bit about Boosters law. According to Boosters law, if an unpolarized light which has electric field vibrating in the plane and electric vector vibrating perpendicular to the plane of the paper, it is incident at an angle IB, then a part of light get reflected and another part get refracted, and the reflected light is found to be possessing only the electric vector which are vibrating perpendicular to the plane of the paper, and also the refracted light has only the electric field vectors which are vibrating in the plane of the paper. So that's how by refraction light can be polarized, but this angle of incidence has to be a particular angle of incidence for a particular interface. Suppose this is air and this is a medium, denser medium having refractive index mu. Now if the angle of incidence is that particular angle of incidence when the light gets polarized, this reflected and refracted ray at this particular condition will be perpendicular to each other. So if we write Snell's law for the refraction at this interface, then we can write sin IB is equal to mu sin R. Again R is 90 degree minus IB. From the figure you can cross check. So we can write this mu is equal to sin IB divided by sin R, which has a value 90 minus IB, and this will give rise to cos of IB, and hence it implies mu is equal to tan IB. And we all know that the refractive index can vary from 0 to infinity. Okay, and again we have got mu is equal to tan IB. So this implies that 1 less than tan IB, that is less than infinity. So tan 45 will give rise to 1. So that is what we are writing here. Let this be as it is, and this infinity can be written as tan 90 degree. Okay, so if we take inverse of all this, then you can see from here it obviously implies that IB is less than 45 degree, sorry, greater than 45 degree and less than 90 degree. Therefore the angle, Brewster's angle IB must lie between 45 to 90 degree for a given interface. And here the third option is giving that answer. So this is the correct answer for the question. Thank you.